Now coming to the next question. Okay, so now coming to the next question. Now again, that's again a very important type of question. I put this type of question as a particular type. Okay, now first of all, again, see, does this equation represent a proper polynomial? Answer is no, but of course we can convert it to a polynomial by replacing 5 raised to the power x by t here. So let's do it. One more thing, when we are replacing any such function by a variable which has some constraint over domain or range in particular, like in the previous question which you would have seen yesterday, its solution, there I replace ln x by t, but since range of ln x is from minus infinity to infinity, so the variable t doesn't need any constraint here. But this time here we know that exponential function can't be negative, so we should know that whatever polynomial we are going to get in terms of t will be a valid equation only when t is positive. Okay, so when we will be looking for the roots of that polynomial equation in terms of t, we have to ensure that only those roots will be valid roots for which t is positive. That means the positive roots will be the only valid roots there. So now let's write it in terms of t here. So what is it? So it's 2 times t raised to the power 4, then minus 3, 9, 3, 2. Okay, so minus 3 times t cube minus 9t square, and then plus 3t, I think, then it's plus 2, yeah, plus 2 equal to 0. Okay, now that's the type of question which I was talking about, and that is if you have a even degree polynomial. Okay, so listen to me very carefully, bachcho. If you have even degree polynomial such that the coefficient of the highest degree term and the least degree term constant is exactly same, and the coefficient of the second highest degree term and the least linear term, second highest degree term and linear term are same in magnitude wise. They may have different sign, but they are same magnitude wise, like 3 minus 3. If this would have been 6, so this could be minus 6 or plus 6. Okay, so the second highest degree term coefficient and linear term coefficient, they should be same in magnitude wise. They may differ in sign. Okay, likewise the third highest degree term and the quadratic term there must be same magnitude wise. Their coefficient should be same magnitude wise. They may differ in constant. Okay, they may differ in sign. And then of course, since it's a even degree polynomial, you will have a middle term. So the point is, these two are same magnitude wise. The least degree, the constant term, and the leading coefficient should be exactly same. If that happens, then the normal approach is divide by this term here, the degree of the middle term, divide by the term having degree as of the middle term, so t square. So divide by t square. What do we get? We get 2 times t square minus 3t minus 9 plus 3 by t plus 2 by t square equal to 0. Now that's what we get here. Okay, now see, we will collect the similar looking term like t square here, 3 by t here, and t here. So let's now collect those terms. So it is 2t square plus 2 by t square, and then it is plus 3 by t minus 3t, and then I think it's 9 minus 9 equal to 0. Now let's do it. So 2 common, so it's t square plus 1 by t square. If I take minus 3 common, so it's t minus 1 by t minus 9 equal to 0. Now see, the beauty of this term, t square plus 1 by t square, the beauty of this term is it can be written as a perfect square of t plus 1 by t. Now you can say, okay, any such a square plus b square can be written as a minus b whole square plus a plus b whole square. The point is that you get a constant. Okay, you just need to add and subtract a constant, or you can write it as t minus 1 by t whole square plus 2. What are you going to choose? Of course, is to be decided by this term. will be decided by this term here. Okay, so now of course we will be doing it in terms of, or writing it in terms of t minus 1 by t whole square, because that's the term we have here. So 2 times t minus 1 by t whole square plus 2 minus 3 times t minus 1 by t minus 9 equal to 0. So now what? We got a quadratic in terms of t minus 1 by t. Okay, now see, at times the whole objective of the approach is to get a quadratic, because quadratic is one equation which we can solve in every possible situation. Okay, and any equation whose degree is more than 2, we are not sure that will we be able to solve it exactly or not. So if we get a quadratic, that means we have achieved that the milestone from where we are sure we will get the answer. Okay, so we got it. So now I will say let t minus 1 by t be replaced by a new variable p here. So let's do it. So what do we get? So we get it as 2 times p square, and then it's minus 3p plus 4 minus 5 equal to 0. So now see, easily anyone can factorize it. So same here. So minus 5p plus 2p minus 5 equal to 0. So it's 2p minus 5 and 1 is p plus 1 equal to 0. So either p is equal to minus 1 or p is equal to 5 by 2. Now these are two possible cases here. Okay, now what is p? So p is t minus 1 by t here. So therefore t minus 1 by t is either minus 1. So now take LCM. So it's t square plus t minus 1 equal to 0. It has of course two roots, and what are those two roots? So minus 1 minus plus minus under root of b square minus 4ac, I think root 5 if I'm not wrong. Bachcho, now it has two possibilities. T is equal to minus 1 plus root 5 by 2, or t is equal to minus 1 minus root 5 by 2. Now tell me, which root are we going to expect here, or we are going to accept here rather? We are going to accept here. So of course only positive roots. That's how we started. Okay, so the only possible root for us here is, so that's not the one we will be accepting. So that's the root we are going to accept here. So one root we got from there. Now the second possibility is t minus 1 by t is equal to, what was that? So another value is 5 by 2. So it's 5 by 2 here. So if we take LCM, I think we will get 2t square minus 5t plus minus 2 rather equal to 0. Now that's easily factorizable. So 2t square, is that so? No, it's not. No, it's not. Okay. So let's write it. So t is equal to 5 plus minus under root of b square 25 minus 4ac. So 4 4 16. It's I think 31 by 4. Okay, now see, root 31 is greater than 5. So here again only one root we will be accepting, and that's the positive root, and this one. So how many real roots does this equation has? So this equation has number of real roots, so answer should be 2 here. Okay, so that was, again I will keep it as a very important question because of this form. Okay, so remember this form. If you get any polynomial in this form, that's the approach, that's the normal general approach we follow to solve such a question, bachcho.